So what is actually the logarithm? Logarithm is that suppose taken as any number real value, that is a, which has the power x. So it can be said that x is the index of the power. Okay. Another number is taken as that is n. So how could you define the logarithm in this case? So logarithm of the number n. What? The logarithm of number n with respect to the given base. A is the base. Logarithm of number n with respect to the given base is the index of the power. Is the index of the power to which the base is to be raised. To which the base is to be raised in order to equal that given number, equal to the given number. That means if a to the power x, which is equals to n, then it can be said that logarithm of n base a, which is equals to x, or we can say that x is equals to, that is, log of n base a. Okay, so here if we take the equation, that is a to the power x is equals to n, a is called the base, x is called the index of the power. Here we can say that x is logarithm of n with respect to the base a. So it can be written as x is equals to log base a n, or log n with respect to the base a. Here we can take some examples such that, that is 2 to the power q. Suppose 2 to the power q, which is equals to 8. So we can say that take the exponent first. It is the important. Okay, so 3, that is 3, the exponent, index of the power, that is 3. 3 is log of 8 with respect to 2. 3 is the log of 8 with respect to 2, or it can be said that 3, which is equals to log 8 base 2 with respect to base 2. It can be written like that, or you can say that in other way, that is log 2 to the power q, which is equals to 8. You can write also in this form. Okay, whatever feasible, that's same. Another example, suppose taking, that is a log base 2 64, which is equals to 6. Again, log 4 base 64, which is equals to 3. It is because 2 to the power 6 is equals to 64. Therefore, logarithm of 64 with respect to base 2 is equals to 6. In this case, 4 to the power q is equals to 64. Therefore, logarithm of 64 with respect to the base 4 is 3. Means logarithm of same value may be different. It's depend upon the base. Again, we can take that 2 to the power minus 2. That is 2 to the power minus 2. So index of the power is negative. Remind it, index of the power is negative, which can be written as 1 by 2 to the power 2, which is equals to 1 by 4, which is equals to 0.25. Means it is positive. It's a positive number. Okay, so therefore index of the power, it may be positive or negative. If the base is positive, then the answer is positive. The value, whatever the result we are getting, that is positive. So what we get, that is, so we have what we have, that is, if a to the power x, which is equals to n, but the condition is what, a to the power x never is equals to minus n. Means whatever the base of the index x, that never gives you the value negative value, that never gives the negative value. Okay, for any real x, that is for all real x. X may be positive or negative, means it may be positive or it may be negative, but whatever may be the value of x, a to the power x is never is equals to negative of a number. Okay, n belongs to r, you can take n belongs to r or whatever it may be. Okay, it never gives the negative value. Therefore, we can say that logarithm of negative quantity. So logarithm of, that is log of negative quantity, is just imaginary. That is a imaginary quantity. Okay. Now take some special cases or case studies. So first case we are taking, there is if a to the power 0 which is equals to 1, a to the power 0 which is equals to 1, which is implies log 1 base a. Log 1 base a means logarithm of 1 with respect to base a is equals to the exponent value which is equals to 0. ठीक है? Means if here is 1, whatever may be the base, the value will be 0. What it gives? Logarithm of unity is 0. So we get the result, that is log of unity is 0. Means logarithm of 1, whatever may be the base, you will get always 0, because a to the power 0 is 1, 2 to the power 0 is 1, 4 to the power 0 is equals to 1, 1 lakh to the power 0 is equals to 1. Means here the logarithm of unity is equals to 0. Second case, case 2, what we get? So another case we are taking, let 2 to the power 0, taking 2, let's taking 2, there are some cases, 2 to the power 0 is equals to 1, obviously. Then what we can say, that is log base 2 1, means logarithm of 1 base 2 which is equals to 0. If we take 2 to the power 1 is equals to 2, in this case what we get? Log that is log base 2 and 2 which is equals to 1. 2 to the power 3 is equals to 8. What we get? Logarithm of 8 base 2 which is equals to the exponent value, that is 3. So here are some cases, but here the value is 2 2 2. If we take instead of 2, we can get different values. Okay, means logarithm of 3 to the power 0 equals to 1, 3 to the power 1 equals to 3, 3 to the power 3 equals to 27. Means we can get the logarithm of 1, 3, 27, like that. But here is a problem. If we're taking the base as 1, what we get? 1 to the power 0 is equals to 1. We can write log 1 of 1 equals to 0. Obviously, that's true. 1 of 1 is equals to again 1. We can write log 1 is equals to 1. If we take 1 to the power 2 is equals to 1, we can write log 1 of 1 which is equals to again 2. Means the same value, log 1 base 1, log 1 base 1 and log 1 base 1. In every case, the same logarithm gives the different values. Logarithm same, but the value is different. Therefore, logarithm could not be defined for base value is equals to 1. So base is equals to 1. If base is equals to 1, log is not defined. Not defined. So what we have actually, the condition. What is the condition? If it is taken logarithm of n base a, which is equals to, suppose, x. In this case, the value of a, which is never is equals to 1, because for 1 it is not satisfied. Then what is the value of a? The value of a we can take, so therefore we can take the value of a as a must be positive, means it is greater than 0. Second condition, a must be less than 1. Not must be, that is a should be greater than 1, it could be defined. Again, a is greater than 1 for a greater than 1. So logarithm base a, the base is defined, means logarithm could be defined for base a greater than 0, means a is positive, that is a is positive if a is less than 1 but not negative, and a is greater than 1, okay, means greater than one number. But for a is equals to 1, it is not defined, so a must not be equals to 1 and not negative. So this is the basic concept of the logarithm. Now let us take some properties of the logarithm.